The Arctic, a vast, frigid landscape that remains largely unexplored. And yet, we realize that it is crucial to understand the future of our planet. This remote region is warming nearly 3 times faster than the rest of the Earth, which has had a global effect. From changes in ocean currents to global weather patterns, the effects on the region are clearly not trivial. But France has a solution in mind to study these changes before it's too late. It's committed a groundbreaking $38 million to the creation of a unique Arctic research station, the Tara Polarstation. But why is this project so incredibly expensive? And what makes it one of the most challenging engineering feats in modern science? Before we start, please make sure to support our channel by clicking the like button and following us so you won't miss any updates on the latest mega projects. The Tara Polarstation isn't just another research vessel, it's an engineering marvel. This facility is built with the intention of being able to drift with the Arctic ice for extended periods of time. This feature would enable year-round research in one of Earth's harshest environments. Let's dive into the technical innovations that make this station so revolutionary and expensive. Unlike traditional research ships that cut through ice, the Tara Polarstation is designed to lock into the ice and drift with it. This allows scientists to cover vast areas without repositioning every so often. Due to the unique nature of the project, the design of the ship had to be created using some radical rethinking. This process leads to its oval hull shape, unlike the standard ship structures we're familiar with. 4 decks will stack up to a height of 11 meters, which includes 3.6 meters below the waterline. The hull's oval shape, similar to an olive pit, allows the vessel to rise with ice pressure instead of getting crushed. This is crucial for surviving months trapped in drifting ice flows. Another important aspect that had to be considered was building a vessel that can handle temperatures plummeting to minus 52 degrees Celsius and withstand the immense pressures of shifting ice. The hull alone is made from over 6,000 individual aluminum pieces, each measuring 20 millimeters thick. Aluminum was chosen for its lightweight, corrosion resistance, and flexibility in freezing temperatures. However, welding aluminum this thick is extremely challenging and costly, requiring multi-pass welding techniques to ensure structural integrity. The Tara Polarstation was designed by Olivier Petit, one of the architects of the schooner Tara, and the Tara Ocean Foundation. It took 5 whole years of collaboration to design both the station and the mission itself. The construction process for the station took 18 months and required specialized shipyards, equipment, and expertise, which added significantly to the project's cost. Every part of the station had to be modeled in 3D before assembly. From the moon pool, a central shaft for lowering scientific equipment into icy waters, to the fluid systems and mechanical rooms. This digital blueprint guaranteed that each component fits seamlessly, which is an absolute necessity when working with high-precision components in such an extreme environment. With a mission length of up to 500 days, the Tara Polarstation's power system had to be as self-sufficient as possible. It runs on 29.7 cubic meters of hydro-treated vegetable oil, HVO, which grants the station incredible fuel autonomy. This reduces the need for costly resupply missions in one of the world's most remote areas. But fossil fuels alone wouldn't suffice. In line with modern environmental standards, the station is powered by a hybrid system of solar panels, wind turbines, and third-generation bio-based fuels. This renewable energy setup not only reduces emissions, but also doubles battery life. This is key to ensuring reliable energy even during the long, dark polar nights. Inside, the Tara Polarstation is built for cutting-edge research. Its modular laboratories are state-of-the-art and reconfigurable, allowing scientists to adapt lab spaces depending on the research needs of each mission. This adaptability is essential, as each expedition might require a different focus. It's equipped for anything, from studying marine biology and cellular biology to analyzing atmospheric changes. Modular lab designs allow scientists to investigate a broad range of research questions without extensive retrofitting between missions. The station is equipped to constantly disseminate up-to-date information, especially through the use of satellite communication. Talking about satellites, another major expense comes from the station's advanced satellite communication systems. Operating at 80° north, where satellite coverage is limited, the Tara Polarsstation's communication setup ensures that data can be transmitted continuously. This is to keep scientists connected with global research networks. This constant connectivity is essential for coordinating with international teams and sharing real-time data. But such tech comes at a high cost due to the specialized equipment required for reliable communication in such remote and harsh conditions. The station also includes a moon pool. This is a vertical shaft that extends from the deck to the waterline. The moon pool is for collecting water and ice samples without leaving the station, even when it's surrounded by ice, which wouldn't be pleasant considering the temperatures. So, what's the breakdown of this $38 million investment? The construction costs alone are massive, given the station's specialized design and use of high-end materials. Every element had to be reinforced or custom-built, from the hull and superstructure to the laboratories and energy systems, all of which is important to withstand the extreme cold and prolonged isolation. Operational costs add another layer of complexity. Maintaining a fully functional station in the Arctic involves substantial logistics, from transportation of supplies and fuel to crew and equipment. Funding for the project comes from multiple sources, including the French government's France 2030 plan and the EU's Next Generation EU initiative. This financial backing underscores the importance of the Tara Polarstation not only for scientific discovery, but also for France's strategic interests in the Arctic, where the geopolitical stakes are higher than ever. The primary mission of the Tara Polarstation is to study the Arctic's rapidly changing environment. As this region warms 3 times faster than the global average, the changes are unprecedented. Everything from sea ice and marine biodiversity have implications for the entire planet. One core research goal is to investigate how Arctic marine species are adapting, or failing to adapt, to the warming temperatures and shrinking ice. Scientists will conduct year-round studies, something that's rarely been feasible in the Arctic before. Understanding these species' resilience or vulnerability is crucial for predicting broader impacts on marine ecosystems worldwide. Another focus is the health of the Arctic ecosystem itself, a vital component of global climate regulation. By monitoring shifts in biodiversity, ice thickness, and ocean chemistry, the Tara Polarstation provides data that can shape international climate policies and conservation efforts. The station's location makes it an ideal sentinel in the Arctic for observing changes that foreshadow broader environmental shifts. A multidisciplinary team of scientists will work aboard the station. The station is designed so that the crew members will be able to enjoy a fully private space in winter. The structure can accommodate around 12 crew members composed of sailors, scientists, journalists, and artists in the summer. Together, these crewmates can tackle complex research questions from every angle. Whether it's analyzing atmospheric changes, studying the behavior of organisms within the ice, or mapping the chemical shifts in ocean currents. This collaborative approach is essential for developing a complete picture of the Arctic's ecosystem and the far-reaching effects of climate change. Beyond its scientific mission, the Tara Polarstation represents a strategic presence in a rapidly changing Arctic landscape. As ice melts, new shipping routes emerge, and untapped resources like oil, gas, and minerals become accessible. Countries such as Russia and China have already staked significant claims in the Arctic, increasing infrastructure investments and declaring geopolitical interest. For France, the Tara Polarstation is more than a research facility. It's a strategic foothold in the Arctic, asserting France's stake in this contested region. By leading in polar research and maintaining a physical presence, France strengthens its influence over future policies governing the Arctic and demonstrates a commitment to preserving this critical environment through science and diplomacy. The Tara Polarstation stands as a testament to what can be achieved at the intersection of science, sustainability, and international cooperation. Its $38 million price tag isn't just the cost of a floating lab, it's the price of safeguarding a fragile ecosystem. Despite being such a technologically challenging project, the Tara Polarstation has high chances of success due to its resilient, ice-resistant design and modular laboratories built for adaptability in extreme Arctic conditions. As this advanced floating fortress is set to embark on its mission, it brings hope that humanity can better understand and maybe even mitigate the climate changes the world has to face. But with every success comes a lingering question. Will the knowledge gained from the Tara Polarstation be enough to drive the urgent global actions we need to protect the Arctic? And could we truly be successful in safeguarding the world from the effects? If you enjoyed this video, please make sure to leave a like and support our channel by subscribing.